Hopefully things will go smooth. And let's kickstart this. Hi there, everybody. I'm Juliana Fagiardini. I'll be your host from OISF today for our monthly Suricata webinar today with my colleague Lukáš Šišmiš. Before we get started, a few words about OISF. OISF stands for the Open Information Security Foundation, and we are a US-based nonprofit organized to build community and to support open source security technologies like Suricata. Funding for us comes from donations from world-class security organizations committed to our mission. If you would like to know some of our consortium members or become one, because sponsorship is always welcome, do check our page oisf.net/consortium members. This is for later, just a brief shout out. This month is Maintainer Month, and I would also like to say that OISF is the organization responsible and that makes Suricata stay open source for all these years, 15 and counting, and it does so much to ensure that Suricata remains secure and innovative and up-to-date and interesting. And yeah, that's it. Without further ado for now, Lukáš, the floor is yours. Thanks everyone for being here, and thanks Lukáš for preparing this presentation.
Thank you, Juliana, for introduction. Okay, let's do this. Okay, you should see presentation now.
Yes, I do. I forgot to mention, folks will be answering the questions by the end of the webinar. Okay, so use the Q&A feature and we'll check them.
Okay, hello everyone. Today I prepared a little webinar around some new features in Suricata 8, and also I wanted to show at least how I achieved running Suricata in non-root mode in DPDK, because it took me some time. I thought it would be worthwhile to share as well. But first, let's see what are the new features in Suricata 8, especially from the deployment side. Here is some quick recap. What do we have? So some features like hyperscan caching helps us to get a faster start time. So we cache, as we will see in a second, we cache the hyperscan some preloaded files onto the disk, and that will help us to start faster, and also, I mean, also reload faster. Each or most of the features I would like to show practically and live. So hopefully the gods of the demo will be with me and nothing will break. Then we will run our DPDK auto configuration. So there is the automatic configuration of DPDK interfaces, which hopefully will help to easier deployment. Some performance update is mainly that previously we had one mempool per interface. Now we have for each worker a separate mempool. I will get to it, and then just the minor feature that's for better statistic, it's the link timeout feature especially for the Intel cards. Okay, so the first feature is the hyperscan NPM caching. NPM is the kind of the multi-pattern matching phase in Suricata, which extracts basically one content from each rule in Suricata and tries to match it. It's it tries to extract the fast patterns from the rules. And it will only consider the rule if the fast pattern is found in the traffic. So it's kind of a pre-filter in Suricata. And of course, Hyperscan is one of the pattern matching engines, along with EO Jurassic. And for Hyperscan, we also introduced the caching mechanism, which saves the preloaded Hyperscan files to a disk. You can enable it in the Suricata detect part of the Suricata YAML. And generally, it will store in one of the installation locations. So in this case, it's the prefix was /var, so it will store into /var lib suricata cache SGH. This feature is enabled by default if you just take Suricata 8 config or compile Suricata from scratch. But if you just upgrade, then unless you add these two fields, it will be disabled. One thing to consider is that the destination path, so this path must be writable by the user running Suricata. This especially applies to when you are dropping privileges, when you are running Suricata, or I don't know, maybe usually it's for that. Or if you are running Suricata as a regular user when you are just reading PCAPs. And this also applies on rule reloads. Okay, maybe let's have a quick demo. So I'm on a machine that's Oracle Linux 8. I have just for the later, I have DPDK version 23.11, and I have Suricata installed in a regular this is my Suricata. So this is basically the compiled Suricata from Suricata 8.0 beta tag, and it's installed in the general location. Okay. So considering we have some rules, I just installed it. So if we will have a look. Nope. If we just run it. Maybe, it will now compile all the rule set. I wanted to enable the more verbose mode, but we will see it anyway. It now starts basically, and the new files will be in that folder as I showed. I need to wait a little. Yeah, that's why it's really useful, this feature to have, as the startup times can be pretty long. I previously I measured it. It of course depends on how many rules you have, but with the ET open rule set that's loaded by default, it took over a minute. We can see here that rule caching loaded nothing because it's like a new installation, and it newly cached the 106 npm groups. Now, when we look at the folder, we see a bunch of different files. Generally, these files don't really interest us, but if you would have any problems, this is the location where they are stored. So basically, what are these files even? As the ET Pro or whatever rule set you have is generally a list of rules that needs to be splitted into smaller groups to make it more manageable for Suricata to detect some alerts. So this rule set is generally split into it's called signature group heads, but like signature groups that are divided by the protocol, the direction, and source or destination port. Now we are in some smaller rule group, and this signature group head contains the specified signature which are relevant for the, let's say, protocol direction and port range. But the signature group head also contains the npm contexts of various interests, let's say. But one of the most used ones are the payload contexts. So basically the patterns which are looked into the packet payloads. Then in HTTP URIs, file data, and some other HTTP buffers. Basically, the sticky buffer each sticky buffer has separate npm contexts, which are the collection of patterns relevant for that sticky buffer in the given signature group. And what are the files? These files are the individual npm contexts. Okay, and yeah, we can also see that previously it took when I measured it was over 70 seconds. Now it should be more like 30 seconds because it just loads the file from the cache. Here we see the updated loaded 166 npm groups. Of course, it would work also on the rule reloads as well. I wanted to show, but I think let's move on just so we have enough time. This is how it works in general. I think I explained it already. On the first startup, we saw that the npm databases, pattern databases were compiled, and on the next run, they were just loaded. If you load it with some new patterns or even rules, if you just add the rules, then the whole database does not need to be recreated completely, but only it only adds the newly or the changed pattern databases. So it if it contains some of these files, and if some of these files are suitable even with the new rule set, they will be used. Otherwise, new caches will be new cache files will be created. Since the name is just a hash of the overall pattern database, we might expect some collisions, but well, during our testing, it's didn't happen to anyone I know. But if it does, and if it's just one-time thing, you might have hit some old npm cache that will be rewritten on the start. But if it's if the warning of hitting the collision is reappearing on every startup, then you might consider switching off the caching mechanism. Okay, so another feature is the DPDK auto configuration, which basically means with DPDK interfaces, you can set the auto to the general configuration properties like the threads, mempool size, mempool cache size, RX takes descriptors. Previously, you had to set an account for like how these values are connected. In Suricata 8, try to auto-calculate. And what auto-calculate means is basically the threads, it takes the most threads it can. If you have what it takes the number of threads which you have defined in the threading section. But if you have multiple interfaces defined, it tries to redistribute these threads evenly across the multiple interfaces. So if you have 10 CPUs configured in threading section, 2 interfaces, each will get 5 threads. Then mempool size, or I will start with RxTX descriptors. This is known from AF packet as well, but generally with Rx descriptors, it tries to allocate the most descriptors it can. And with TX transmit descriptors, it tries to set 0 when it's running in IDS mode, and again the maximum value when it's running in IPS mode. Then it takes these values of the RxTX descriptors and calculates the mempool size. Below we see basically here we see the basic calculation for the mempool size. And the mempool cache size is again derived from the mempool size. What generally what I would suggest that you are only configuring at most the Rx and TX descriptors, and leave the mempool size and mempool cache size up to Suricata. So with this change, we are hoping to really reduce the way that you need to think about deployment and configuration of DPDK interfaces to minimum, and basically also improve some throughput. But it might also mean that if you previously had a lower number of Rx descriptors set, and now it will automatically set to higher, then you might need a bit more huge pages. So that's basically up to you what you want to prefer. If I show the carbs here, So in this server, what really interests us are the E810 interface card and the Mellanox or NVIDIA ConnectX card, which we will be working with. So let me look. So in DPDK section, I have, let's say, now configured the AF00.1 interface, and the mempool size, Rx descriptors, and everything set to auto. Now when I run Suricata, I will now disable rules to improve the startup time. We can see that we can see that it configured the 4K receive descriptors, and in the warning above, we see that basically the network card adjusted our descriptors a little bit. So the Rx descriptors stay the same, but when we cannot actually set the 0 descriptors to the E810 NIC, so it's adjusted to 64, and that's fine. Basically, we get what we wanted, and that is the maximum number of descriptors. The mempool size was automatically calculated to cover the amount of configured descriptors. When we now, let's say, run the Mellanox or NVIDIA card, we will see that that card will be able to handle 32,000 descriptors. That generally, from my experience, has a better impact on the throughput. Okay, that was fast. Here we clearly see that the Rx descriptors are set to 32K, and we also have the 0 TX transmit descriptors. Okay, and then we have the DPDK link timeout. Oh, okay. Sorry. Before that, I wanted to highlight now that what I mentioned previously, instead of setting up one giant mempool which holds all room for all the descriptors, we are now creating 4 smaller or whatever the amount of workers are mempools. This helps with scaling, basically, as we observed, for instance, with Andres when evaluating for septum 3. We observed that basically per worker mempool has better throughput, so we went with this way. So thanks for that, Andres. Okay, and the DPDK link timeout is used or implemented because some NICs are ready to receive traffic only after you start the port. Then it takes a few seconds to set them actually up. So let's see. This mainly applies to the Intel cards. It doesn't affect the Mellanox cards. So let's configure again the Intel one. The link timeout is specified here. It's by default disabled. Let's see the effects. So now when it starts, and I immediately stop, I basically see 0 packets, which is not true because on this interface, some packets are coming in smaller rate, but still some are coming. This basically means that we started the port, but the port wasn't really ready. So we get a bit of fake statistics. If you run Suricata for days and months, it doesn't really matter, but it especially matters when you are just testing out things. So now we said that we want to wait at most 10 seconds for the interface to be really up and only then really start Suricata. So now to reach the we started line, yeah, the threads created line, it takes a little bit longer, but now whenever I can or I shut down the Suricata, then we always will see at least some packets. Yeah. So that's why this was implemented, especially when you are testing. This can be pretty helpful. Okay, and yeah, we are coming to the second chapter of this webinar. That's how to run Suricata as a non-root with DPDK. This can also apply to Suricata 7, by the way. But I will just follow up on this webinar and we'll continue with Suricata 8. Why we want to do that is basically one main argument for that is the principle of least privilege. So basically to limit the resources what Suricata has accessible. In the end, it wasn't like that brutal, but yeah, it required some fiddling around. I will work with ConnectX 6, but it worked for me for other NVIDIA cards as well. And we will also show how to set it up on Intel E810. In general, we need to create a separate user, allocate huge pages. There might be, let's say for the Intel card, I had to set up some specific VFIO PCIe things, and then you can run it as a user. I brought a little cheat sheet, and I have the server pre-configured, just so we don't run into any issues. Basically, in the first 2 lines is the usual creating a Suricata group and Suricata user. Then in the for loop, we are making sure that the general Suricata directories are accessible by or owned by Suricata user. That's pretty easy. Then what is different is the actual configuration of capabilities on the binary. With DPDK, it's a little bit different in that I never really managed to configure the drop privilege. So in this webinar, we will not cover the run as option for now, at least. As DPDK was really quite protesting. So in this case, I'm running Suricata directly as the user, as the say unprivileged user, and for this reason, we need to set some extra capabilities. The IPClock basically means that it can lock the memory pages. And the capabilities is nice is for the thread affinity configuration, which, I mean, is really helpful when you are configuring the affinity of the threads. So I configured this. Let's check it out if I have it configured correctly. No, I have here I have more. So I will take I will set it up properly. Okay. So now with getCap, we verified that, yep, we just have these two capabilities configured. We can proceed to the next step. The next step is reserving the huge pages. So in general, what you are maybe used to do is just to run DPDK huge pages, set up to G, let's say, and it automatically sets it up. In this case, we need to make the huge pages accessible to the unprivileged user. So at least the exact commands are like this. So first we just reserve the 8 gigabytes or of the memory. For this, I created specific folder to say in this folder will reside the huge pages. Otherwise, it's, I think usually it's like /dev/huge pages. You make the folder owned by Suricata user and group, and then you mount the huge pages on this folder for the particular user and group. One thing that is always worthwhile to check when you are doing the DPDK huge page reservation, first verify that with the status option that huge pages mounted are only on mount Suri huge pages, and that is now, so that's fine. We can also check I saw some root files there, but at least the folder is owned by Suricata, so that's and must be from the previous runs. But the folder is owned by Suricata user and group. Okay. Okay, and when you are at this point, we can just run Suricata as the user directly for NVIDIA cards. So let's check Suricata YAML. I think, yeah, there is the Intel card. We will get to it in a second, but let's first configure the Mellanox card or try it out. Okay, so that's configured, and now I'm root. Let's try it this way. Okay. Nope. So the gods are not with me. Let me try to fix that.
If your demo went only smoothly, something would be wrong. So
yeah. Let's first check. Okay, this is implemented. I'm Suricata. Now I'm root. Yeah. I will try to run it as from sudo. This is Suricata, but that shouldn't really help. Yeah. Let's try to fix the huge pages. I think that's the most probable cause. So let's we will unmount from directory. Okay, so that's unmounted. Now let's clear it. That's unmounted and cleared. And let's try to reserve it again. Yeah, it's empty now. Okay, so these are configured. Huh. Maybe the capabilities are too low. Let's try. This is a bit of overkill, but let's just make sure we can run it. Yeah, we can run it. Okay, so that's a good sign. I don't think we need this. We need some of that. Okay, so we'll need to work on the capabilities. Just before the webinar, I tried to reduce it down to the bare minimum, and that's what probably bit me. So I will reinspect that and follow up on that. But just so we are not stuck here, with a bit more capabilities set to the binary, we can now run Suricata. And now let's have a look at the Intel card. So VFIO is the say device driver, requires some let's a bit more operations or commands what you need to do. First thing first, oftentimes you see mod probing or invoking the VFIO PCA driver with the unsafe IOMMU mode. I actually tried it this way, and yeah, I wasn't really successful with this. But when I actually modified the kernel parameters, as you should, I just did a quick experimentation. Generally, you shouldn't use the enable unsafe no IOMMU mode, but you should edit the kernel parameters with these two switches or configuration options. You just rebuild the grub, reboot the server, and then should be able to just mod probe or invoke the VFIO PCI driver and not need anything like the unsafe no IOMMU mode. So that's why I'm just here probing the VFIO PCIe. For this case, I added a separate group VFIO to which I added Suricata as the user. And then this VFIO required some extra rules so that Suricata user has access to the VFIO devices. Here we can see that basically the /dev/VFIO will be accessible by the VFIO group to which belongs Suricata user. And the commands below are just how to trigger the device management system in Linux to make sure we got it set it up properly. Now, when we look at the /dev/VFIO, we see that these are owned by the root but by the group VFIO, and that's fine. And then the DPDK dev-bind can bind the VFIO driver to the Intel drivers, to the Intel cards. So when we again re-verify, you can see that we have this binded, and that should be it for the VFIO. So now we can start INO. So now we can configure again the Intel card in our configuration. And just run it as the Suricata user. And we are off. Most of the errors are caught somewhere where you are initializing the DPDK. So usually it complains somewhere there. If you get past that stage, then it's all good. And yeah, we can see that it's initialized. And yeah, basically, those are the things that I wanted to show you. We covered it all. And I'm ready for the questions.
Cool, thank you. I love that you have this approach where you share the things that did not work out and what you did instead. It's cool because so often we make things sound as if everything went perfect from the first try, and that's so not true.
Yeah.
We have 2 questions. Some a bit was answered in the chat, but I think it's good to have your perspective. So Fandi Gunawan asked, is there any drawbacks by using Hyperscan NPM other than collisions? Because you mentioned that.
Well, it's the Hyperscan itself is not linked to collisions. So it can be definitely used without caching if you are worried about that. And the collisions can be definitely detected that Suricata should not start up if warning pops up. I think, what's that? I think it's something like init on warning. So that would definitely prevent you if you have any collision. But yes, considering the Hyperscan is the most performant NPM engine out there, I would I would definitely recommend using Hyperscan either with or without the caching. Okay, I see the init errors fatal. Okay, maybe the warning isn't there as I expected. Other npm engines don't have this caching mechanism implemented, but they are also faster at, let's say, preparing the matching structure, the run mode structures. So usually the Suricata startup is also faster with the AAC mode, with the IHOP Karasik. npm algo, yeah. So the auto mode basically means it will try to use the Hyperscan if it's available. Maybe it will be in the close future replaced by vector scan, which is just which is fork from Hyperscan. But regardless, any of these two should offer the best performance capabilities for you. Okay, think.
Then we have another question by Andreas Dolt. What are the main differences between DPDK and AF packet? Can DPDK be used on lower end Intel cards as well? Like for instance, X710 or i350, etc.?
Yeah, no, I'm not sure about the 350. Maybe if I would know the device driver, I could tell. X710 can definitely be used. Although I generally have suboptimal experience with Intel cards, and I'm generally recommending NVIDIA cards. You can try. There are some deployments where Intel cards work just as good. And that's why the Intel cards perform less optimal or suboptimal is because of the, at least from what I observed, is because of the RX descriptors. Because those descriptors in DPDK serve as the only buffer that the network interface card has. And Intel cards only allow setting up to 4K descriptors, whereas the Mellanox cards, NVIDIA cards, allow 32,000 descriptors. So the buffers is bigger, and when the peak hits, then yeah, you have more buffer to smooth out the performance. And with the lower, going more lower end than X710, let's say, it's possible. It can be a little bit tricky. Generally, with DPDK, you should aim for the high performance for higher performance deployments. Although the idea was also to reuse the older hardware to achieve a bit better speed. I assume it would also help to have a bit of community testing on this. We could use on that. Sometimes the AF packet can be as performant as DPDK, but especially for other applications, DPDK is considered to be much more optimal if you are working with bare metal than AF packet.
Andreas added that the driver for the i350 is IGB. You said that maybe if you knew the driver, it could help demonstrate.
Yeah, I'm like 80% sure that it's supported. Generally, DPDK has the supported NIC for the hardware list. IGB. Nope. Okay, so it was the iXGB. So yeah, that's not supported. The i40 is for the X710, but not yours, unfortunately.
But it's good to know where you can go and check what's supported or not.
Yeah.
I think those were the questions, folks. If there's any other question, please, now is the time, or then you'll have to like go to our forum or the Discord.
Yeah.
Thanks.
I mean, my plan, sorry for interruption. My plan is to basically write it down, considering it's the commands. Then it's always helpful to just copy paste them. So my intentions are to make blog posts of this webinar as well.
That's
so it's
great.
more accessible.
Yes, please. So I will then take over again just for a few wrap up words. Thanks, Lukáš, for this great presentation, folks. I hope you enjoyed as well. And bear with us for a few more minutes, not many. We are still on time. I just mentioned our forum and Discord. Those are the best ways to be in touch with our community or ask questions, to stay up to date when we have more webinars or we publish anything to our YouTube channel, when we have new releases, anything. So go there to chat with the team and the rest of the community. There are awesome folks there. As you know, I hope you do, Suricon this year will be in November from 19 to 21. Tickets are now already available. It will be in Montreal. The call for talks closes soon, so in case you want to be there to present whatever awesome things you are doing with Suricata, run and submit your talk. We love to hear what you have to say, so please don't miss this chance and don't hide what you're doing from us. If you want to check the rest of the contents that we have for Suricon, go to suricon.net. You have the archives and everything there. One more thing is that this year we have made it easier to have the trainings and the Suricon discount bundled. So if you go to our Eventbrite, you see those options. Sorry, I forgot to add a link to that, but maybe Kiel or Lukáš can drop that in the chat. Again, as I said, the call for talks for Suricon is still open. Go there, suricon.net/call-for-talks, or just scan this QR code and share what you've been doing. We have 3 trainings this Suricon. Kiel just shared that information, and all of them are awesome. One is for deployment as usual, one is for advanced threat hunting analysis, and one is for rule writing, because last year we had it and folks really liked it. So go to suricon.net, you'll find all of that and more. Thanks once more for joining us today. And as you know, either this week or the next, ideally, we will publish this webinar to our YouTube channel. Thanks a bunch to all of you. Thanks, Lukáš, for being brave enough to bring a demo presentation. It's always scarier to have those. And well, you did awesome. You shared stuff. You shared the things that work and that don't work. And this way we all can learn. I'm looking forward to that blog post. And I think we did a great work. Any last words?
No, thank you. It's really great on the intro. You are a pro now.
No. I just try to keep improving as we do all. And now I have to learn where to stop recording because I always, okay, there it is. See you all on the next month with another webinar, hopefully. And I hope to see many of you in Suricon later on in November. Go enjoy the rest of your days and have a nice weekend.
Yeah, thank you all. Bye-bye.
Bye-bye.